Okay, the topic of today's video is properties of rhombuses, rectangles, and squares. Our objective, I can use properties of rhombuses, rectangles, and squares to distinguish them from other quadrilaterals. So just a quick refresher, a rhombus corollary. Quadrilateral is a rhombus if and only if it has four congruent sides. So we have our four congruent sides. And remember, rhombuses are parallelograms, so we have our two sets of opposite parallel sides. Next, rectangle. A quadrilateral is a rectangle if and only if it has four right angles. So we have our four right angles, and again, our two sets of opposite parallel sides. And lastly, a square. Quadrilateral is a square if and only if it is a rhombus and a rectangle. So for that to happen, we have to have our four congruent sides and our four right angles. So from there, we're going to do some always, sometimes, or never. And number one, a rhombus is blank a parallelogram. And as we know from our quadrilateral family tree, a rhombus is always a parallelogram. Next, a square is blank a rhombus, as we just saw on the last slide. For a quadrilateral to be a square, it has to be a rhombus, so a square is always a rhombus. And third, a rectangle is blank a rhombus, and a rectangle is sometimes a rhombus, and that is in the case when a rectangle has four congruent sides. In that case, it would actually be a square, but it can still be defined as a rectangle as well. So, an example, figure PQRS is a rhombus. We want to solve for our unknowns, x and y. So we'll start with the side lengths. We know a rhombus has four congruent sides, so we set our two side lengths, y plus 8 equal to 3y. Solve for y. Subtract y here, subtract y there, we get 8 equals 2y. Divide both sides by 2, and we get y equals 4. Okay, and now the angle, we have to remember back to our last video when we were talking about parallelograms, because a rhombus, as we know, is a parallelogram. And we have the theorem that states if a quadrilateral is a parallelogram, then its consecutive interior angles are supplementary. And supplementary means they add up to 180 degrees. So to solve for x, simply subtract 104 from 180 to find x. That will leave us with x equals 76 degrees. Moving on, a couple theorems here. Parallelogram is a rhombus if and only if its diagonals are perpendicular. So we have our parallelogram, our two sets of opposite parallel sides, and then our diagonals are perpendicular, and the definition of perpendicular means that they create a right angle. So it won't just be this angle right here, it'll actually be all four of these in here are going to be right angles. Another theorem, parallelogram is a rhombus if and only if each diagonal bisects a pair of opposite angles. So we have our two diagonals. We see that this one, AC, will dissect angle DAB and also angle BCD to give us two congruent angles, four congruent angles actually. and our diagonal DB bisects angle ADB and CBA to give us another 4 congruent angles. And our third theorem, parallelogram is a rectangle if and only if its diagonals are congruent. So we have our two sets of opposite parallel sides and our two diagonals. We can see that this is congruent to this and the other two are congruent to them as well. So the diagonals of square DEFG intersect at point H in the middle. And if we are told that EH equals 5, we're going to try and find the measures of these 4 unknowns. So, measure of angle GHF, we remember our theorem, we know that these diagonals are perpendicular because a square is a rhombus. So if these diagonals are perpendicular, we know this makes a right angle. So that is 90 degrees. Then measure of angle DGH, we know that the diagonals of a rhombus bisect opposite angles. So if this was a square, we know that angle DGF was initially a 90-degree angle. So if we bisect a 90-degree angle, we get angle DGH is 45 degrees. Now the measure of angle or segment HF, we see that this is one of the diagonals, and we know that all 4 of these diagonal segments are congruent, so we know that HF is going to be 5. Now DE is a little more tricky, since all 4 of these diagonal segments are the same length. We can mark these as 5, 5, and 5. We know this is a right angle as well, and that this angle here is congruent. All of these angles are congruent. They are all 45 degrees. So if we know that we have a 90-degree triangle, or right triangle, with 2 congruent angles, we know that those are 45-degree angles. We have a 45, 45, 90 triangle. And so to find the length of DE, we know that this length is x square root of 2, with 5 being our value for x. So DE is going to equal 5 root 2. And the third one, KLMN is a rectangle, and we want to solve for our x and y. So we start with y. This is a rectangle. We know it's a parallelogram. Parallelogram has 2 sets of opposite congruent sides. So this side length is congruent to this side length, so we can set those equal to 0. 3y plus 10, not equal to 0, I mean equal to each other. 6y minus 50. If we subtract 3y from both sides, we get 10 equal to 3y minus 50. Add 50. 60 is equal to 3y. Divided by 3, and y is going to equal 20. For our x, we know that these are all congruent to each other. So we can set x plus and set x plus 50 equal to 90. Subtract 50 from both sides. We get that x equals 40 feet. And for our review, just again, viewing the always, sometimes, never to distinguish between our shapes in this one. A rhombus is always parallelogram. A square is always a rhombus. A rectangle is sometimes a square, and a rectangle is sometimes a rhombus. Make sure to go online, do that reflection, get those points, and we'll see you tomorrow.